Well, you wanted to see a 10 on 10 problem, now you got one. This is for anyone taking an integral calculus course that wants to see solutions to a really tough exam problem explained clearly. If you can get this one, you're totally good for volumes of revolution on your exam. Trust me, you're totally good. This one's hard. Find the volume of the solid resulting from rotating the region enclosed by the curves. Y equals 4 minus x squared. Fine, that's just a parabola. Starts at 4, goes down, no problem. And y equals x plus 2. Easy peasy. That's a line that's going like this. We got a parabola on top and a line like this. What's so hard about this? About the x-axis. Okay, I can still do it. I can see that. Using the method of cylindrical shells. That's hard. Let's set it up. I just want to point out, it's not the method that's hard. Method of cylindrical shells is generally fairly straightforward. 2 pi r times height. But let's look at this region that we have here. Here we have the line. Here we have the parabola. This is the region that it encloses. We have to rotate this about the x-axis and use shells, not washers, but shells. Ouch! We have to split it up into multiple integrals. This part here from x equals 3 and above is going to be its own integral, and then this part here will be its own integral. We have to use shells for both. That's why I say if you can do this one, you're ready for your final, for this part, for this skill. If you want to see good exam problems like this every single day, take a second to subscribe. I'm going to keep pumping them out. All right, back to the question. Let's find the point of intersection. Let's find, this one's pretty, well, we won't have this graph, right? I gave you this graph. So you're gonna have to algebraically solve for these things or draw this graph on your exam. Neither of the functions are difficult. You can do that. Or algebraically, we just set them equal. We solve x is equal to -2 and x is equal to +1. Perfect. We can get those intersection points. That's going to be helpful. Now, to use shells, we're going to have to integrate with respect to y. We can't use shells and integrate with respect to x. Another reason why this is an excellent exam question. Skipping a little bit down, for the first integral, we have the height as being one side of the parabola minus the line. Let's go see what that looks like. That's this side of the parabola minus the line. That's the height, is the difference between the two of that's the height of our shell that we're going to use. Going from y equals 0 up to y equals 3. And now we need to think about what's the second integral? What's the second thing that we're going to have here for the height of the shell? It's just 2 times the parabola. Let's look. That makes sense here. So for x between 3 and 4, it's just, see, it's double this parabola. There's 1/2, there's the other. Once you've set all that up, we do some u substitution. It's not terribly difficult, but it's not terribly trivial either. I'm Sheldon, I have a master's in math from Waterloo. I used to grade these exams, and now I show you how to ace them. So you can see the full solution on the site. I've also got tons of really tough exam problems like this. If you got an exam coming up in integral calculus, go check it out. Might help you out.